How you doing today, bud?
I'm doing good. How are you?
My voice is a little hoarse. I was at Universal for 14 hours yesterday.
Oh my God. Wait, what Universal is like a theme park?
Yeah, Islands of Adventure with my sister, her husband, and their 5 kids. All 5 kids actually did pretty good considering and my brother and his girlfriend, considering that we were there for 14 hours. But
Wait, what is do you get there at 8 a.m. and leave at 10 p.m.?
Yes, sir. It was actually, I think we actually ended up leaving closer to 9. So it was like a little bit more than 12 hours.
Okay. Still, it's impressive.
Yeah, it was a long one. My feet hurt at the end, but it was fun, man. We saw the new Harry Potter world, which is pretty cool. They have like they have a part where you go into like the area in London, Diagon Alley, and it's cut off from the park, so you feel like it's like totally immersive. Whereas like the rest of Universal and Islands of Adventure, you can kind of always look around. You're in Jurassic Park world, you can see Marvel Island. Here you're like completely covered by like the buildings. Feels like you're in London. There's like a dragon on the tower that like breathes fire. It's pretty cool. It was fun.
Nice.
Anyways, lots of screaming on fun roller coasters and all that good stuff. Eating fun park food. So yeah. I'm feeling like I was on my feet for 14 hours yesterday.
Nice.
But it was a good time. Cool. So today we're going to continue our streak of our podcasting here. And we are going to be talking about React Server Components today. So Dan Abramov had a tweet thread where he asked people to ask him questions about it. And we basically went through and picked out some things that we thought were interesting to talk about, some stuff that's here, some stuff that's kind of vision for the future, and figured we'd just kind of react to, no pun intended, to our favorite posts here. So we have a YouTube channel for this podcast that we have videos on. So we're doing screen recording right now, and I'm just going to go ahead and share kind of my notes and the tweets as we go through them. So in case you want to follow along with that, you can do that. But let's go ahead and get started here. This was the last thing we were talking about. I want to make sure we cover this before we kind of finish because I think it's really interesting. Mm-hmm. Maybe we'll get to that sooner than we think. But let's come back to the beginning here and start with some of these that we picked out. So just while I'm doing this, is anything you want to do to tee us up here? You've been using React Server Components in Next 13 more than I think I have, or maybe a lot of people have.
Yeah, I've got 2 apps that are Next 13. One uses Prisma, one fetches from like a GraphQL API, but they are both server components, and I really like it. Sort of like feels like it's kind of a work in progress just because you don't have the mutation stuff, which you kind of hinted at. But I think it's really exciting because when it reminds me of a lot of the stuff that I felt like I had to give up when I got into React and client-side apps. So just like using ORMs, having access to a database, having code run on the server. It feels like all that stuff is back on the table. So I'm really excited. So
nice.
Yeah.
That's awesome. I think a common theme I saw in this thread and all the replies, the conversations he was having, is that people not really getting what the benefits are, or the benefits aren't being explained clearly enough to people saying, I'm already server rendering my React apps. I've been using Next forever since get server-side props or get initial props, right? Which like pre-renders things on the server or builds them on the server. I use Remix, which renders my React app on the server. So why are server components giving me anything different? So I think that's going to be something that comes up a lot in this.
Yeah,
even
to answer what I just said, where I said, like, I love that I can use an ORM. Well, couldn't you have done that with get server-side props? And I think there's some good questions here that we can get to.
Definitely. Okay, so this first one, there is a conversation here about how this is kind of the same idea, how it compares to other solutions that help you get data across the wire with React. And there's a bit of conversation above this, but here Dan says, if another solution, and I'm talking about how it compares to React Server Components, if another solution does an SSR pre-pass, that's bad because it just re-renders your app again and it throws away the actual result. I know why it was needed, but in React 18 we can actually do streaming rendering that pauses. The pre-pass is bad now. So there's a bit more conversation here, and then he says React Server Components is more like data to output, not data to output plus seed data. So the reason we wanted to highlight this here is because this again gets us this idea of how React Server Components are different from what we do today. So today, there is only one type of React component. And when you build a React app, you end up with a tree of React components, which are only client components. Server components are a new thing that are additive, right? They don't take away anything from the kind of React that we write today. They are a new feature. But today, all of our React apps are like subsets of like React Server Component apps. Like they're React Server Components like in a vacuous way because they don't have any React Server Components. But when you have a client tree, which is what all of our apps are today, you can pre-render it. This is like a term we've been using just to help us clarify, because you have server rendering, you have server components, you have like server-side rendering. It's really confusing. So I think the easiest way to think about what happens with React apps today is that they are pre-rendered on the server. So if you have a client tree that has things like use state, it has event handlers, it has animation hooks, it has context and providers, all of those APIs are able to be pre-rendered on the server, because you kind of want to get some HTML output so that when you first render your app, you're not just looking at a blank white screen until React initializes and does a render. So this is how like it used to work with Ember, right? And then Ember got pre-rendering, you know, and that's kind of what happens with React. The first version of Create React App would do that, right? It would render a blank white screen, and then sometimes you would ship like a spinner in the initial HTML file that would get replaced once React rendered. That was crappy for a lot of reasons, and so now we can pre-render it. And of course, with tools like Next and Remix, there's different gradient of solutions, from pre-rendering it at build time to pre-rendering it at request time, right, at runtime. Mm-hmm. But regardless of any of those tools, which ones you use, when you load a React app today that's not a server component app, you're seeing a pre-rendered client tree. The JavaScript, the React script, then loads and hydrates your client app on the client. It hydrates it, meaning it uses the HTML that it finds in the initial version that came from the server to attach all of the interactivity, the event handlers, the state, and then it starts running on the client. So, yeah.
You could think of like the most crudest form of hydration could be like you just delete everything that was pre-rendered and like rerun the React app. In a sense, that's kind of what's happening. Like you can be like smart and say like, oh, I can keep this block of HTML around. But in a sense, you are rerunning the React app on the client now, like, you know, from entry point and running through the entire tree again.
Exactly.
As you were talking about us pre-rendering on the server, I think a good way to think of that is like you are running the browser on the server, rendering the React app, and like capturing the very first frame of output. So like you're not, yes, you are running your React app on the server, but it's like running the React app on the server by your server, like booting Chrome, like running the JavaScript and then capturing the output. So it's not, you know, it's not running on the server in the same way like
there's a loop. There's not like a loop that's waiting for like events or something like that.
Exactly. Yeah, exactly. Mm-hmm. Anyway, yeah, just
I think
it's
that's
like good.
It's getting 100%. It's getting a snapshot, right? And you can think about it like you need to call for someone to be able to hover a card and to grab it. You need to like call add event listener in the same environment where their mouse is moving, which is the browser. This is why we call add event listener in effects, because it doesn't make sense to add an event listener when you're running this code in the server, right? So you're getting a snapshot, like Ryan said, from Chrome, and you're getting the initial HTML. That's useful for viewing. That's like a useful thing for viewing, but calling add event listener doesn't make sense for that. So like Ryan said, you can just literally throw it all away. It's like, oh, we get to see the initial article because it's coming back from the server in the HTML. But to do anything interactive, we need to blow it away and actually init the app. So framed like this, you can actually see how hydration and pre-rendering of client trees, client apps, is kind of like a hack. I mean, it basically feels like a huge hack because the experience of looking at like a spinner and waiting for the client to render is just, it's bad. Funnily enough, that's what we do with native apps, right? When you open up Twitter, you look at a splash screen and then the app renders on the client, but of course apps have a benefit of being downloaded and all this stuff. In our case, you need to tap a link and you want to see something useful. So we said, well, better to just pre-render it and show them something that maybe they can start reading the article before they tap a button or try to drag a card while we wait for it to just basically be thrown away and re-rendered, right?
Yeah. It's also makes it really, really hard to have conversations with like Rails developers and PHP developers because you have to do this extra step of work where their work ends at the pre-rendering
right
phase. Now you could make the argument that like, well, we need to do this because we need client-side interactivity, but it's really, really hard to win that initial argument where like, wait, you're rendering on the server, then you're re-rendering again on the client. Like, guess what? I get to do half as much work as a PHP developer. I get to do half as much work as you. Like, you can't compete. Like, you just can't compete. You're playing a game. You can't win.
Yep. Now, interestingly, you've said before, like, this is not like a huge, you can get into the nitty gritty of this, like, and the fact that the app is like re-rendering on the client and hydrating, and it's like, maybe it's not our biggest problem. But on the other side of that, I guess you could say, like, this whole idea of hydration is something that anyone working on React has to be aware of, because you will encounter hydration errors, and you will encounter oddities by trying to run your code in different environments, like pre-rendering it in the browser, pre-rendering it in the server versus rendering it in the browser. So that is a reality of this model, right? And I think those are symptoms of the fact that you are trying to pre-render this thing, and it's like this whole, like, since we started doing this and like making modules work in ES6 and in CommonJS, like, there is just an impedance mismatch between these two environments. And I think what this conversation and its whole research with React Server Components is helping me understand is that hydration and pre-rendering of a client tree was never the best way to take advantage of the capabilities of the server, right? Because it's just a hacky way to try to get your component to give you some initial render that's better than a loading spinner, but to really take advantage of the capabilities of the server, kind of needed something else. And I think that's a big part of the motivation for why all of this research and all this work is happening, in spite of the fact that we've had pre-rendering for so long,
Yeah, I mean, if I were, okay, so the way I would phrase this is, we're laying out this hydration stuff because we need an answer to how is this different than something like that server-side props. But there is more that this unlocks. This is just to help you understand what is the difference. Like, why do we need server components when we have get server-side props? Okay, they're fundamentally two different ways of rendering, and we just kind of went over how get server-side props works, where you're capturing that initial render on the server and then using that to seed the client.
Right.
But server components do sort of a different thing. And
Yes, exactly.
Kind of
so we can keep going, but that kind of wraps us up nicely. But that's what he means when he says React Server Components is more like data to output and not data to output plus seed data. So hopefully that kind of gets us all on the same page there, and how this is kind of different. So let's see where we're going to go next here. So again, kind of related. No, the next one. It says, is it possible to get hydration errors in server components? This is just to kind of reiterate and really drive home this point we just made. server components by themselves cannot have hydration errors inside. Okay, so maybe we should talk about what server components are now that we've talked about hydration. So let's go back to that that diagram, because I think this is going to help as a mental model. I think I think between that section, if everything we said actually makes some sort of sense, and this, it will answer a lot of the questions that I saw come up a lot in the thread, because it clarifies a difference here. So this is a pretty cool illustration here Dan posted about the mental model for server components. So on the left here, I'm going to explain this out loud just for people listening, but you can see it if you look at the YouTube video, or I'm going to include some of these links in the notes so you can see the tweet. And so this is the mental model for React server components and how they run. You're basically looking at a HTML tree, 3 versions of it, from left to middle to right. On the left, the first one is the React server component tree. The middle one is the client component tree. And the right is the HTML tree. Like, the right is the end result. If you open up your DevTools, what you would see in the DOM. It's what gets added to the DOM and shown to the user. So I actually think it makes sense to start with the middle one here, because the second one is what we all do today with React. We write React apps that look like this middle tree here, which is just HTML body, div, and then some client components like a theme toggle or an add comment form that maybe animates in a modal, right? This is all just React today. And so he's calling this is like a client tree. And if you haven't been following this stuff, server components that are being introduced are distinguished from client components, and client components are basically what we call React components today. We're going to say something?
I was going to say, just why don't you talk through the green part? Like,
right. So
how does this work?
Right. So client components are what we have in right today, which have React features like use state and use effect. And so whenever we write a React app today, it's like this middle one. So again, for people listening, not looking at this, the components that are green here, capital components, are client components that have things like context, state, and effects. So what happens today when you render a React app? Well, you pre-render it like we just talked about. It gets shipped to the front end. That gets blown away effectively and then hydrated. And then React attaches things like event handlers and the state system and everything it does on the client. So let's say that you render this add comment component and it has a click event listener that will open up a modal, animate open a modal, right? All that is happening in your React app. When you click the button and then you call set state somewhere to is showing modal true, that triggers a re-render. Just good old React, right? This is what we know and love. Triggers a re-render on the client, and that causes the DOM diff to occur, and then you see the new app. So that's all happening in this kind of from the middle version of the tree to the end of the tree, and that happens over and over and over again. Now, server components introduce this kind of first step on the far left. And again, just to describe what's here for folks who are just listening, we're seeing a tree of components, but there are green components that are clients that are being interleaved with blue components that are server components. They're both at different levels of the tree, mixing and matching. This is going to turn out to be another key point of kind of the opportunity that React Server Components presents to be able to, what's the word I'm looking for?
Compose.
Same
paradigm.
To be able to
every time, if you're not paying attention and someone asks you a question and you're in a React conversation, just say compose.
It's like answering Jesus at Sunday school. It's basically always going to be the right answer, even if you're not paying attention. So they're able to compose with each other at different layers of the tree. So we have a page component at the root that's blue. That means it's a server component. We have a theme toggle wrapper that's a client component. That makes sense that would be a client component. It's a green client component because the client is what knows the user's preferences on whether they're dark mode or light mode. Again, this is a great illustration of kind of like using each environment where it makes sense. Then we have a post page with some post text and some comments. Those are all blue. They're server components. And then you have our add comment button, which is the client component. So the idea here is like right now, the main benefit, the main thing that you can do in a server component, the main reason you'd want to start using them is because they make data fetching easy. So you write them as an async component. They run on the server and they can fetch data directly from something like Prisma talking to your database. And this is what happens first. So this tree that I just described, this gets rendered and turned into the second version of the tree, which is exactly equivalent to the client apps that we write today. It's almost as if the server components are getting rendered away. They're getting rendered out of the tree completely. The post is getting turned into an article tag with paragraph tags. The comments server component is getting turned into an unordered list with list items. But those things ostensibly they are fetching data and then being turned into that. And so this is a really awesome illustration of a few things. First, that server components are an additive technology. They're an additive feature. You can take a client app and then add server components to it, and you get these benefits that you get. But it's an additive thing. It's not like there's no breaking changes here to React. Any environment that has the capability to run React server components will be able to run any React app that you've ever written before because it's purely additive. So if you see the React core team talking about that, that's what they mean. The second is what's the point of all this, right? What's the point of having these blue and green components here and going through this first pass and then a second pass? Well, if you have been writing React apps that fetch data and that are dynamic, which most of us have, you're either using hooks from frameworks like Next, like get server-side props, or a loader function from a framework like Remix, or you're doing what we did for many years using client-side fetching solutions like SWR or React Query. And the main idea here is that all of those are solving basically the same problem, and they share a lot of common challenges when it comes to data fetching. How do we connect to the data? How do we revalidate data if we need to that's gone stale, refresh the page, share data fetches that happen across different parts of the tree? And so React Server Components is attempting to solve this with a single model that it composes across the whole ecosystem. That's kind of the point of these things. And so if you've never written a server component yet, these components here will literally look like an async function that can await a call to a database. And again, these are running in the server only. So this is the difference. A client component, a client tree, is pre-rendered on the server. It's sent over the network to run on the client and then blown away and hydrated, and it runs again. Server components never exist in the client. They only run on the server. They get turned into their output. That output is sent up to the client app in like this compressed, like efficient format that you might hear referred to as wire data, and it's slotted into the spaces that the holes for the React server components in the tree. And but that's it. They're never hydrated because they're compiled, like they're rendered away by the time the React app starts running. So yeah, it
was great. I think like looking at this, one of the main benefits I see is, again, you can look at the far left tree and I can look at this and I can tell you exactly what each one of these components do. Similar to a React app, the client-side React apps we write today, you can tell what each one of them do. But then the fact that the server stuff what did you say? It gets rendered away?
Rendered away. It's tempting to say like compiled away, but it's not, right? It's rendered away because one thing I didn't mention is when these get rendered, because it actually is incidental. It doesn't matter. There's some times where you are going to render server components ahead of deploy time. Again, I don't want to say pre-render because that's just more confusion. I like using the term pre-render to discuss what you do to a client tree in the server. You can render out a server component tree once at build time, let's say, if you're fetching data from like a CMS that doesn't change that often or something. But ultimately, they are intended or made capable of being rendered at request time. So when a request comes in, if you're looking at this, you can go through this whole stage at request time, right?
It's
these stages.
It's really cool that one of the things we have talked about a lot over the last week or so is single paradigm. And it's really cool looking at this, knowing that like I can write a React component that fetches data and renders like an article with p tags, but I can also write a React component that renders a button that lets you change from dark mode to light mode. And the fact that I can write those components and just render them side by side. It's all as if I'm writing React, but I'm optimizing like my code for the best environment. So the code that loads data is going to run on the server, and the code that has the interactivity is going to be marked to run on the client. And I think that's really cool. I think that's cool that you don't have to think about how I'm going to fetch data and thread it into my React app. If you need to fetch data, you can drop in a component that fetches data. If you need to add interactivity, you drop in a component that adds interactivity. This is a thing that makes the PHP developer in me jealous.
Right. It's exciting that, like you just said, you now have this requirement where you hover a person. You used your controller code in your PHP app or your Rails app to fetch the tweets for the home feed. But now you need to hover a user's avatar and show how many followers they have. So you have it's a different enough problem that is hard to model with the existing conventions because it's not a page load that's fetching data and rendering a list or whatever. And whatever you end up doing there is going to look different from what you do in the first place. It's the same thing when we were doing Ember apps too, where Ember has a similar model to what Remix does, where it has a loader that blocks a navigation on a fetch. And but then you want these UI cases where you want to fetch data within the page. It's not a navigation. So part of what this is going for is like you just said so well, a general solution that I can fetch data, whether it's tied to a URL or tied to a mouse event, in the same way. If you're going to be writing a React server component app and you have a component that needs to fetch data, it's going to be a server component. It's going to look the same, right? So that's pretty interesting. Obviously, this is all very new, and a lot of this conversation is like a vision of the future. But that is, if folks are saying like, if you're wondering there's a promise or a potential here, and why we're not just sticking with like the data fetching methods from the frameworks that we already have. That's it. That's it right there. Because, for example, in Next.js, get server-side props is great for initial render. But if you want to fetch data on hover, like you're not going to really be able to do that with get server-side props. You're going to bring in SWR. Exactly. Right. Something.
You have a button to load more posts. Your different paradigm, different way of thinking.
Exactly.
Fine. You can get stuff that works. But yeah. Can you talk a little about like, okay, so when we started looking at this, we talked about the client app, and you do like a click that increments like some state, and the client app re-renders.
Yes.
How does the server
components
app
re-render?
Re-render. Yeah.
Good. Yeah, because we hadn't quite finished. So the picture shows the client app in the middle, and it shows a click event, which sets state with re-render. That's the green cycle here. But there's a blue cycle that goes from the end state all the way back to the beginning. And we said the beginning, the tree of server components gets rendered away so that they literally don't exist from the perspective of the client. That's one way to think about it. And it's like, well, then how does it ever change? Well, there is some knowledge there of which segments of the UI are tied to server components, and then there are APIs for basically invalidating those server components or refreshing them is another way to think about it. So in this diagram, they show you submitting a form, which was traditionally something that would have a server-side mutation, right? That's going to go back all the way to the server, something like a form submission or a mutation that changes data, or a navigation. Let's say you're at post/1 and you navigate to post/2, right? Our post component is a blue server component that's using the post ID to fetch the article and the contents from a database and render it. So if post ID changes from 1 to 2, we need to re-render that. That's what tools like Next and eventually other frameworks that use RSC will provide you with, a way to do that. And so they are going to have, there's no mutation API yet. So the easiest way to think about this is like a navigation. Let's say that post component is a server component and you use the dynamic router params. So you use params, right? Which again is integrated in this framework in some way that is aware of the router. So now React knows that this server component depends on the param in the URL. If that changes, I need to re-render it. That's going to kick this all off again, right? That server component might be rendering a totally different tree of different client components. It could change everything about it. So it could have a conditional where it renders an add comment and then a conditional where it doesn't, right? So after your server component tree re-renders, basically, you're going to get a new client tree. And then that client tree could pre-render, and then it gets hydrated again, effectively. But the crazy thing is that you could do all that while maintaining any client-side state you had. So if you had a counter, it could stay the same if it was still rendered in both outputs of the server component tree. So that's why these things are have to be deeply integrated, because you need to be able to re-render these portions. And even if you get a different client tree, it's almost like the two client trees are going to be diffed, right? That's probably exactly what happens. But if there's a search input in your header, it doesn't matter. It can maintain that state on the client. So
I think this is this is when I've used this is one of the mind-blowing cool parts. Just the fact that you can ask the server for new data. It's almost like calling window.reload, right?
Yes.
In a world without I was going to say without JavaScript, but that's a JavaScript API. In a world without React, you just
right.
I need to refresh the data, just call window.reload. This lets you reload the server components, but keep all the client components that you've already had rendered if the output from the server component has them. That's kind of a weird caveat, but
Right.
Which means that, if you have inputs or you have counters or you have whatever, you have just interactivity, all that stuff stays on the client. So you can think about this as just refreshing the parts of the page that change. Actually, that's how I think about it.
No, that's a great way to think about it. If you have a comment list and you want to load more comments, just because you want to load more comments in the bottom of this part and you already have fetched your nav and someone is searching a term up here and they've clicked their notifications, you don't have to jump to a different paradigm. You are just rendering a server component with new props, like page 2. It's an async component that fetches data and is appended to the screen. It just re-renders the part of the screen that changes. It just so happens that that's running in the server and fetching data directly from your database. But you don't have to now leap to this different paradigm just because we're not doing a full page navigation.
Yeah. Yep.
Which is awesome,
nice.
Because even in Next.js, there's a single root layout, but there's kind of a couple different hacky ways that you can make this happen with nested layouts. React Router has nested layouts and Remix has nested layouts, but their loader paradigm is focused. Typically, the emphasis is on URL loading. There's different ways to load data that's not tied to navigation, but again, the idea here is what if we could just do all those together in the same way? And it actually doesn't matter whether you're loading a page for the first time, you're clicking a blog post for the first time, or you're clicking view more comments at the bottom. All of those things can be modeled in exactly the same way.
It's really nice. It's really nice. Just hearing you say that, it's really nice just knowing that it's just going to be a regular React tree, just like I'm used to writing. And when a component needs to fetch data, like my more comments, I can look at the query param, see what page I'm on, and fetch everything up to that page.
Right.
It's pretty nice.
Seems really nice. There's more we could talk about here, but I want to get to some of the points that we had pulled up too, because I just think it's interesting to think how this would work, how the mutation API will work, how will we actually let the backend know it needs to change these parts. Right now, Next 13 is beta version, lets you change, invalidate segments based on whether they access query params or URL params and stuff like that. But it's not complete. What does it look like here? But that's just kind of in the future. So I say we set that aside for now, and we'll be able to talk more about that when those that RFC and the work gets started there. I think with that conversation, some of these will make more sense too, and I found them useful to kind of read and just think about. Something Dan said here in response to a question about why couldn't we just do the interactivity from the server without loading React at all. Like you might, if you work with Remix, you might know that a lot of times you can turn off JavaScript and Remix will handle, form submissions. And isn't that a great thing that we can write a React app without the client? Dan remarked here, he said, I think these ideas throw the baby out with the bathwater. Client stuff is good. It lets you add interactive pieces that respond instantly. The urge to get rid of the React script tag is, in my opinion, misguided. But yes, before React loads, we'd want progressive enhancement. So I wanted to call this out because, we talked about last week, like forms and links are actually best modeled with HTTP and HTML. So I think that's a great thing, especially that, Remix has done a great job this last year or two of like bringing that to the forefront of people's minds. But if you're writing interaction code, you're, dragging a Trello card and animating something on hover, all the things we like doing with React, that's what React was designed to do. The goal shouldn't be to eliminate that just because we are trying to find an abstraction that helps us do things in the server that make sense there. And then it's not that we're abandoning all the cool stuff that everyone's built with React and the ecosystem has developed over the last 10 years, right?
Yes. This also, well, keep going.
So I think people are saying things like React communities rediscovering like data fetching or how to make websites like the web did 20 years ago, right? We have talked about this over the last few weeks, but the idea is not that we're going to throw away things because we can make things interactive much, much, much more simply. I mean, the things you can do with React are unbelievable. The point is, can we disentangle the parts that make sense to do on the client, which is close to the user, on the user's device, versus the things that make sense to do on the server, fetching a list of posts from our database at the time of the request, not sending over that library code and not doing more work on the client than necessary, not waiting for the client to render and then fetch more JSON from the server. All that stuff just makes more sense and is easier for the developer to do it on the server. Can we do both of those things in a way that look like the first tree on that picture that Dan shared, which is the blue and green components interleave with each other in a seamless developer experience across the whole thing? So I thought this was worth calling out because this is kind of like, this is the main point of difference. Once React understands an asynchronous component that runs in the server and it already understands all the client stuff, it can provide a much more cohesive developer experience that is seamless between the two than if React remained unopinionated about the entire part of the problem space, right?
Mm-hmm. This is a really good, hearing you say that, I think is good because it helps drive home, like, why do I need to wrap some components in use client? Why are some components async data fetching components? And it highlights like this component is going to be taking advantage of this environment. Like the client component gets to take advantage of, the interactivity, the effects, the event listeners, and the server component gets to take advantage of the data fetching that we just talked about.
Totally.
So it's really nice to know that you. I'm kind of like, I'm trying to think how to say this. Like, you're able to take advantage of each environment, and you're not the general abstraction that expands all environments is the React tree, the React components, the way they come together. It's not trying to find a type of component that works in every environment.
Right.
It's like the React tree is a thing that works across all environments, and then you get to pick the component like type per environment. I don't know if that made sense.
No, it does make sense. And there's another quote here from Dan that he says, the question is, what are the downsides of React server components? He says, you have to learn to think in server-client boundaries and how to structure components to rely on composition. So I think this is an interesting point here. This whole point of all this is to have a single paradigm for building UI and building parts of UI that make sense to do on the server, the data fetching and the server components, and parts that make sense to do on the client. Use client features, interactivity, animation, all that good stuff. Now, you might be looking at this and arguing, so Ryan has been talking about use client async function, the way it works in Next 13, which is like the most mature version right now of how to work with server components, you might look at that and say, bro, that's not one paradigm. What are you talking about? Like, this is a server component and this is a client component. Your server component has an async word in it. It awaits calls to the database. Your client component has this use client text at the top, and it calls hooks like use state and use effect. And I can't do the one and the other. That's not one paradigm. It's two, right? But the paradigm is actually the boundary. It's the component invocation and passing props. So that is the important part of React, right? All of the stuff inside. It's the tree. It's the tree.
Yeah.
The tree is actually the single paradigm. And it's all the stuff on the outside. That's the whole point of React in the first place, is that if you give me a component to import, I know how to render it, angle bracket syntax. I know how to pass props. And that's all I have to do. Your component could re-render when the user changes the screen size or turns off their Wi-Fi or crosses a time zone. I don't care how that mess is implemented. That's all that mess that's going on inside. You've given me a declarative component boundary that I can drop in. And because it's built with React, it composes, which means it knows how to trigger re-renders in the whole React app. It knows how to re-render if its props change, because it's all using one paradigm. And so that's why, regardless of how messy that thing is inside, it can slot into my React app and compose in the ways that I had, in the same way as if I had written it myself. So the point of React Server Components now is that we have another component that composes, because it's invoked in the same way. It can pass props to client components in the same way you pass props to any component. And because of suspense, React is aware whether this particular component is taking time to render. It's not ready to render yet. So in the same way I can drop in your GPS indicator component and it listens to the user's Wi-Fi status, I can now drop in a tweet or a web likes presence or comments count. I can drop in a temperature. I can drop in a weather widget in my app. It can fetch data from whoever, from wherever. I don't know. It's inside that messy boundary somewhere. But if we're playing along these rules, it can compose and coordinate with my loading of my app, the loading UI that displays when my own data is being fetched from my backend. That's what the suspense part is, right? So this is why you as the author have to be able to think in server-client boundaries, which is what Dan's saying here. But the benefit is that you end up with still a single paradigm, and hopefully the idea, the goal, the hope is that it will unlock even more collaboration where I can bring in a tweet component that loads a tweet. It can do it ahead of time. It can do it at runtime. It can do it lazily on the client. But that's what the single paradigm composition model is all about. So I thought that was something else worth calling out here, because that is why, even though you have to learn how to use them, and they are different than the client components that we author today, what they yield, what they result in, is this client tree that is a fully composable React tree that plays nice with the whole ecosystem.
Mm-hmm, mm-hmm. I have a question I have a question for you. So this idea of, you pointed out that like use client and an async function is what allows Next to distinguish like a server component from a client component. So basically in Next, if you have use client, it knows it's a client component. If you don't, it assumes it's a server component.
Right.
That function can be an async component.
Right.
Does that have more to do with how Next bundles and builds your app? Or does that have more to do with React server components? Like could there be a different version that uses different pragma or some markings to distinguish? Exactly. Similar. I just think out loud here. Similar, like, could you get that composition that you were talking about with React server components, but also in like a single file?
Right.
Magically, your build tool knows like, oh, this one should run on the server and this one should run on the client.
Yeah. We have to wrap up here pretty soon, so I'll just answer this quickly because I want to just hit these last few tweets. But I think that I don't know the specifics right now. I do know that I think some of it is specific to Next and some of it is is from the React RFCs. I know they've changed a lot. They used to have a convention where they were going to say component.server.js and component.client.js. They tried to have a solution where you have a single file that can export both server and client components, but it was too hard. That uncanny valley where the modules being imported the same way it happens today in Next and Remix sometimes, that you get like common JS modules trying to be imported in the client bundle. So ultimately that's where they landed. And I think they're trying to be as aligned with React itself and the RFC as possible here, because, you know, Sebastian and works and Andrew works at Next on React on Next, right? So they're trying to make it be a really good implementation of the spec, basically. But I do think other tools could experiment with different pragma. I don't think you have to be a React server component. You have to say use client. I mean, maybe that's true, or a client component, right? Maybe that's true. I don't think so. I do think the async function is part of the spec. Like the fact that a server component is literally an async, because they were talking about like a use import from React as a way that you would pass in an async function, and they decided to just make the component an async function. So I do think that's part of React and not Next. But yeah, so that's that.
Yes, that makes sense. React can render async.
Exactly.
On the server. Yes. Yeah. Okay, cool.
Okay, and just here to wrap up, kind of based on what we were just talking about, so you have to think in the server-client boundaries. I thought these were cool to just see because, again, it highlights the point here. Someone said, will this enforce backend app to be developed in JavaScript, or do you foresee implementation in different languages coming up? He says, the primary point is to be able to write regular React components in both environments. Using a different language doesn't let you do that, so I don't see it very compelling. But yes, in principle, it's possible. So again, just highlighting what is the goal of all this. It's that single paradigm approach. And then here's another one that kind of sums this point up nicely. I'd frame the core proposition is that you can write a React app that can take full advantage of both server and client features at any level in the component hierarchy. There are partial alternatives for each particular feature, but not as one paradigm. So again, just kind of driving that point home. So, I think we'll wrap this episode up there. We could always do some more because there is a lot to say about this stuff. It's pretty interesting, but I thought that was worth talking about, and I'll be sure to put this link to this tweet with this diagram up because this really helped me understand what was going on, and I think this diagram's a really good kind of takeaway from this whole thing. So
I agree. I think I actually really like the direction we took in this episode where you do the what is SSR today, talk about this diagram, and then go from there.
Yeah,
I think that helped me.
Because that's what we're familiar with, right? We're all familiar with SSR and pre-rendering a client React app and then hydrating it.
Yep.
So.
Yep.
You could actually put your hand over the left tree and the top blue arrow, and that's what we all work with today. That's React. Yep. And then you move your hand, and now this is React with React Server Components. It's just introducing this new additive step that can potentially happen before the other stuff that already happens. So.
Cool. Okay. I know you got to get going. So,
well, I guess that's all we have for this week. And if we want to talk more about this next week, we certainly can. I need to start playing more with server components for sure. I know you have some apps that work on it, but I'm ready to dive back in.
It's really interesting having this sort of conversation, and then it's helping me realize like what's the difference between a server component in the React sense, and then like how you use them today in Next.js. It's just it's
because there's still some gaps with like the goal, the vision, and everything.
Not just that, just like kind of like just understanding like the use client, how that's like it's like a Next.js pragma, like just given that there's only one way to use server components, and that's Next.js. It's hard to know. Like, imagine there were 3 frameworks that used server components. You could kind of see like the approach each framework is taking. I'm not saying that's like what needs to happen, or
right.
The Next.js implementation is awesome, but seeing it's hard for me to tease apart like which part is Next and which part is React. And this conversation I felt was very React focused. So it's
Mm-hmm.
sort of, it was good because usually when I'm using these things, I'm using Next and I'm only focused on like the whole picture. I don't know. That was rambly.
No. That makes sense. That makes sense. And he even mentioned this in the thread in some of the replies that it's a hard time where they're figuring out how to talk about it, and it involves talking about it, but talking about it in a way that's like not super precise or not fully worked out or still like a work in progress can cause some confusion. But ultimately, it's like it helps shape and form the ideas, right? So yes, I totally agree. Nothing in this diagram, or really anything we talked about today, has anything to do with Next.js, which is a particular implementation of what you could call the RSC spec, right? So there's like a spec for RSC that like describes basically this additive thing. This is like, again, you cover one eye, you're looking at React today, you remove your hand, and now you see like React tomorrow. That's one way to think about it. So
yeah,
pretty cool
very
stuff.
Cool.
All right, well, let's wrap it up there. Thank you all for listening, and we'll catch you next week.
See ya.
Bye.